You've gone to chem class and you look on the board and you see something like this. And you're like, what on earth is that? I thought this was chem class. Where are the numbers? Where are the words? All I see are letters and sticks. Welcome everyone to G Squared, where excellence is epitomized. I'm Gilligil's here to simplify things for you. Now, you saw those organic things before and you're like, what on earth are those things? You know, I'm here to just help you to sort it out. So what you really saw were formulae used in organic chemistry. So today we're going to talk about formulae used in organic chemistry. Now there are basically 6 formulae that we use in organic chemistry, and I'm just going to run through each of those for you very quickly so you can understand them clearly. Alright, so when you're looking at organic chemistry, first of all you need to remember that organic chemistry, there are many different types of organic compounds. And because there are many different types of organic compounds, each of those groups or classes, or what we call homologous series, you know, they have a general formula which represents them. So if a compound belongs to that group of organic species or class of organic compounds, then they must fit into that formula. So the first formula we use in organic chemistry is actually the general formula. So I'm going to give you here an example of a general formula. Now, one class of organic compounds is actually the alkenes, and the general formula of alkenes is CnH2n. Now the N represents the number of carbon atoms. So let's say the number of carbon atoms is 3, then N is equal to 3. And so the formula of that species would be C3H6. Alright, so that's your general formula. There are other classes of compounds with different general formulae. But we're just going to give you the alkene example at this time. Now the second formula that is used in organic chemistry is the molecular formula. And we're going to be sticking with the alkenes. Now let's say there's an organic compound, an alkene, that has 4 carbon atoms present in it. Yeah? So if it has 4 carbon atoms, then N is going to be equal to 4. And so for us to write the molecular formula, which is the formula which tells us the exact number of atoms present, so it gives the formula, the exact formula of a species, then all we need to do is just replace N with 4, and we can easily work that out. So that would be C4H8. Yeah, so moving nicely, you know, so that's your molecular formula. And that's, of course, is the formula which tells you the exact number of atoms present in your organic compound. The next formula would be the empirical formula. So what you're going to do with this one now is it is derived from the molecular formula, and it is the simplest whole number ratio of the molecular formula. So when you look at your molecular formula, if you can divide it down by a highest common factor, then you can arrive at your empirical formula. So let's look at this molecular formula, C4H8. So you can think ahead and say, whoa, 4 can go into itself 1 time and 4 can go into 8 2 times. So I could actually break that down into something simpler. And that simpler thing that you break it down into is your empirical formula. So we could do that. So it would become CH2. Great. So that's your empirical formula. So general formula, molecular formula, empirical formula. The next formula that we want to look at is the structural formula. And we're going to be using the same compound here, C4H8. Now you know it contains 4 carbons and 8 hydrogens, but you're not sure of how those are arranged, what's connected to what. You know, the structural formula now shows you what is connected to what in your molecular formula. So I'm just going to show you the connectivity of C4. So now you can see that our 4 carbon atoms are connected in a chain, but there is a double bond between them because alkenes have a double bond. more on that later on. But then the 8 hydrogens are connected on the outside or on the periphery of those carbon atoms. But you can clearly see carbon atoms connected by these bonds right there. And that is your structural formula. Okay? Then now the next formula we can get is our condensed formula. For your condensed formula is look for your carbon atoms, show any special atoms bonded to them, and any special bonds as well as any hydrogen. So here's what you do. You take each carbon. So this is carbon here, and this carbon is bonded to 2 hydrogens. So I put H2 there. Then this carbon is also bonded to this carbon, but it's a double bond, so I need to put my double bond in. And so then I write the next carbon. This carbon is bonded to that hydrogen, so I put a H there. But it's also bonded to this other carbon, so I put that C right there. It's not a double bond, so we don't need to put in the single bond. Then this carbon is bonded to 2 hydrogens. And it's also bonded to that other carbon over there. And then this carbon is bonded to 3 hydrogens. So that's how we get our condensed formula. We take each carbon atom and write down basically the atoms bonded to it and any special bonds. So that's your carbon with your double bond there, it's right there. Okay? And then this carbon is bonded to 2 hydrogens plus the double bond, this carbon, the single bond, etc., etc. Finally is our skeletal formula. Our skeletal formula is basically our carbon backbone with any special bonds or any special atoms. So we're going to write the skeletal formula for this. And this is the funny part, because all we're going to be writing are lines. We're just going to be drawing lines to represent a carbon atom or a carbon molecule or a carbon backbone for that matter. So let's draw the skeletal structure of this one now. Believe it or not, this is this. Each point along the line represents a carbon atom. So this point represents this carbon atom, this point represents this carbon atom, this point is this carbon atom, and this point is this carbon atom. Very strange. These lines between the points represent the bonds. And as you can see, this is a double line, which represents this double bond. So there you have it. The 6 formulae used in organic chemistry. You have your general formula, your molecular formula, your empirical formula, your structural formula, your condensed formula, and you finally have your skeletal formula. Yes, so there you have it. I'm Gilly Gills here for G Squared, where excellence is epitomized. Like the video, share and subscribe.